All right, today we're going to review and cover percents. Percents are a big part of intermediate math. Introduced in 5th grade, and then 6th grade we start doing percent problems. Junior high we have to spend a lot of time with the percents and percent applications. So with percents, the most important thing is to start at the beginning and understand what percents are, what that symbol means. It means part of 100. If you look at the word percent, cent obviously is the root word meaning 100, just like we use for century, and a penny is 1 cent, etc. So we first of all need to relate this to fractions. Another word to put this is out of 100. So when we're trying to figure percents, we want to deal with out of 100, which relating then to decimals. It's very important to relate both to fractions and decimals. So when we're finding percent, we are finding a part of 100. We are in the hundredths place. Okay, so hundredths place. Part of 100, hundredths. So this is a means of comparing out of 100. So it needs to be related to both fractions and decimals. There's no difference, just 3 different ways. There's really no difference in value between 1/4, 25 hundredths, and 25%. Remember, that's not 0.25, that's 25 hundredths. So the percent is simply the next step in expressing the same amount. All right, another way we could do this is relating it to the fraction 1/4. This is 1 of 4, right? Or 1 out of 4. Well, we want to make it out of 100. So on your simple percents, and this is where 5th graders begin, trying to get them to understand what percents mean. 1 out of 4 or 1/4. If we want to, this then is 25 out of 100. It's equivalent. So basically what we're doing is we're taking a fraction and converting it to hundredths or hundredths. This is kind of a circle, right? Doesn't matter how we express this. 1/4 of the circle, let's say, is 25 hundredths of a circle, is 25%. What's the difference? It's a different way to make this comparison. This is 1 of 4. So then, I'm not going to draw it, but equivalent to that would be 25 out of 100. Or 25 hundredths. Or 25%. Okay? So it's just a different way. All we're doing is we're replacing out of 100 with this symbol. So that symbol means divide by 100. So if I have, keeping a simple example, 25%, to drop my percent sign, I divide by 100. If I do it in fraction form, it gives me the fraction equivalent. If I do it as a decimal, dividing by 100, I'm moving the decimal 2 places. So that percent sign means out of 100, which means divide by 100, or put it over 100. That's another way we could write it. Over 100. Okay, so 25% is 25 hundredths, is 1/4, is 0.25, is 25%. It's just a different way to express the same relationship or the same amount. In your book, we're going to go through section 5.1, how to convert percents to decimals and decimals back to percents, and how to convert fractions to percents to decimals, etc. And if you look on here, it's on page 203, percent just means part of 100. And they've got a little box with 100 little pieces, and then they have it shaded. Obviously, I'm not going to draw a box with 100. But all we're doing is expressing it as a fraction, and that's the first way you want to introduce it, is with a fraction out of 100. So when we are going to convert our equivalents, we have to have understanding of what percent means. And I think this also is sometimes overlooked. We teach our students to move the decimal 2 places. What is that? That's procedure without concept. And then the decimal just gets put all over the place. Then some students, they don't understand what's going on. They don't realize we're dealing with hundreds, and they get in the habit of just putting the decimal in the front. Well, a lot of percents, hey, that works. Put the decimal in front. But that doesn't work when we have 5%, does it? It doesn't work when we have 125%. We're dealing with the hundredths place. So when we convert our percent to its decimal equivalent, we have to divide by 100, or we have to put the percent in the hundredths place. It's always hundredths. That's why it's 2 places. We're not going to just teach our students move the decimal 2 places to the left. What is that? It's a procedure that requires memorization, and when you lack the understanding, you're going to have the decimal all over the page, okay? All over the page, because they're just going to put the decimal where it looks good to them instead of where it actually belongs. So the first step in doing percents is remembering what they mean and what they represent, and understanding what's going on instead of trying to remember what you did in 8th grade, okay? So then as we progress, the first thing we want to do is learn how to and remember how to and understand why we are converting from a percent to its decimal equivalent. So to do so, we are going to divide by 100. Okay, which is the same as dividing by 10 squared, right? Which is the same as multiplying. There's where I want the negative exponent. So dividing by 100 is the same as dividing by 10 squared, is the same as multiplying by 10 to the negative 2 power, which is the same as multiplying by 1/100th. That's what percent means, 1/100th, or out of 100. So when we're going to the decimal, we're just going to be moving the decimal 2 places to the left, which is indicated by the negative exponent. Remember, when we talked about percents the other day, we were talking about the negative exponent and decimal place value. Remember from algebra, remember the number line. Negative numbers are always to the left of 0. Less than is always a number to the left. Left, 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 so you have to associate left with negatives. So when I'm multiplying by 10 to the negative 2, which way do I move the decimal point? To the left. Now, as we get into algebra, we don't do a whole lot of dividing, do we? Not really. Remember from fraction math. If I have 1/2 divided by 4/5, I don't do much division there either, do I? What do I do in fraction math? Everything is rewritten in terms of multiplication. And that's as we progress further and further into arithmetic, and especially into algebra, we'll do less and less division and always think of things in terms of multiplication. Right, but remember the idea here. And right is going to be always associated with positive. Right is also always associated with greater than. So this is the greater than symbol. It always points to the right. This is the less than symbol, always pointing to the left. Okay, so we're going to move the decimal to the left. Tenth is 1 decimal behind. What is hundredth? 2 decimals behind, 2 places behind the decimal. Okay, so we're thinking here in terms of hundredth. That's what this means. Hundredth. And that's what the whole basis of percent is. So it's always going to be the 2 places, not because I memorized it, because that's what it is. It's 2 places to the left according to our decimal place value. So we've got to think of this as hundredth, hundredth. So when I deal with the decimal, I always read it hundredth, hundredth. So when I'm converting 36%, a very simple, easy percent, to decimals, it's no different. 36 hundredths, 36 hundredths, 36 out of 100, 36% is 36 hundredths. Okay? 2 places to the left because hundredths is 2 places behind the decimal. Okay? So then anytime, it doesn't matter how small the percent becomes, I still divide by 100. This one's pretty easy. 5%, 5 hundredths. 1/2 of 1% is 5/10 of 1%. And many people are very happy with that decimal. That's not the decimal equivalent. That's just the percent equivalent. So I have to move that decimal 2 more places, and this is behind the decimal here, so it's behind the hundredths place here. We are converting to percents no matter how big or how small the decimal is. I am dividing by 100. I'm changing the place value by 2 places to the left. This is a tiny percent, so it's going to be a tiny decimal, isn't it? Okay. Otherwise, we'll have students just dropping the percent sign there. That would be 5%. That's 5/100ths of 1%. Very tiny. We also can have percents that become larger and larger. And this is an important concept. When we have a very large percent, students are not going to want to put the decimal where it belongs. They're going to want to stick it in front. So if we have 136%, everybody knows the decimal goes in the front, right? That's what the impressions that some 5th graders and 6th graders get. 5th graders aren't really going to deal with this, but 6th graders will. And in their minds, they didn't hear a thing that I said, and they just remember seeing on the board that the decimal happened to be in the front of all of the percents, right? So, what happens? They're just getting by on procedure and remembering what they saw on the board instead of understanding what the percent is. So we have to do both. We have to try to reach their understanding of what the percent is so they know why we're moving it 2 places, and then we do have to stress the procedure. We're dividing by 100. We move the decimal 2 places to the left, and we have to practice the procedure. All right, so this is autopilot, okay? And students like to use autopilot. They like to sit down, do their homework, and go through it, doing whatever comes to their mind. Some students, not all students. But, so we have to make sure that what comes to their mind is the 2 places. And this goes back to the idea that any number greater than 100%, or any percent greater than 100 is greater than 1. 100% is 1 whole. So this is a mixed decimal. It's greater than 1. It's always going to be 2 places because we're dealing with hundreds, not just random decimal placement. So this is an important thing to stress to 5th graders and 6th graders. I know it's obvious, but it's not obvious, is it? So 100% is equal to 1. So any percent over 100% is going to be a mixed decimal greater than 1. Right? So when we are dealing with percents that become large, a 500% increase, let's say, means it's 5 times bigger, right? Because this is out of 100. So 500 out of 100 is 5. So percents greater than 100 are greater than 1 in either decimal form or fraction form. Okay, so we have to first be able to convert any percent to its decimal equivalent so that we can do computations with it, do operations with it. We can't do a math problem with the percent in, it's not a number. It has to be converted. All right. Then we can't ignore fraction math. And often, many students have fraction phobia, and they're going to default, literally default to the decimal. But many times, actually, the fraction is easier, the fraction math is easier, and if we have a repeating decimal, the fraction math is more accurate. So we can't ignore the fraction equivalents. We can't always default to the decimal point, though many students default to decimals because then they can use it in their calculator. Though today's calculators, you can punch in fractions just as easily as decimals, but not the little cheap calculators that students have, elementary students. Okay, so fractions also then are automatically in terms of 100. The denomination of the fraction is defined as hundredths. So this is, the denominator is 100. So we can always replace the percent sign with the correct denominator, which is always going to be 100 because we're dealing with out of 100. So if I have 36%, I replace that symbol with what that symbol means. And of course, we always reduce. Which we've already trained our students to do with our flashcards during our fraction time, right? Okay, so then it doesn't matter what we've got here. We replace the percent symbol with the correct denominator, hundredths, percent. Even say it that way, 5%. So, changing a percent to a fraction is just a matter of rewriting it in a different form. There's no computation involved unless you count the reducing. So you need to be able to go quickly and accurately back and forth between the three. What if I had 125%? That doesn't change the denomination, does it? It does not change the denomination. The denominator is always 100 when we're dealing with percents. This is greater than 1. So this is going to be greater than 1. More than 1. More than 1. Okay? More than 1. Whichever form we put it in, it's going to be more than 1. It's all based on, literally, based on 100. Whether we do it in decimal, or a decimal in the hundredths place, or in fraction in the denominator. So converting back and forth is not going to be a problem when we understand what this symbol is telling us. It's telling us out of 100, or divide by 100, or hundredths place. All right, so math, of course, is always two ways. The equal sign is reflexive. It goes both ways, doesn't it? So that means the next thing we have to do is go backwards. We have to be able to go this way, both ways, back and forth. Many times when we're doing what we would call a percent problem in our percent chapter is we're going to be asked to express the answer as a percent. So that means we have to do the computation and express the answer as a percent. Okay, and if you think through this in fraction form, it's easier. Let's say I have, let's do 32 is what percent of let's do we'll make it easy. I don't want to do 96. That's going to give me a repeater. I don't want 96. I'm going to do 104. Okay? Think of this as fraction math, and then it's a lot easier. So remember I said before, we don't want to always default to decimals. We want to go through fractions, and often fractions are easier, and sometimes they're a lot more accurate. So I am making a comparison. 32 out of 104. Right? And as soon as I see that fraction, what should my impulse be? As soon as I see that fraction, what should my impulse be? Reduce it. Okay? And so this is going to be 4/13. Oh. Fraction. So in this problem, we're going to have to divide, but would you rather divide by 104 or by 13? By 13. What if I had, let's go with 80. This is even easier. So even when it's not an easy fraction, thinking through fractions is always going to make the problem easier. 32 out of 80, what do you get? 8 goes into 32 4 times, 8 goes into 80 10 times. This is easiest of all. 4/10. Don't go to the decimal, just go directly to the hundredths to go directly to the hundredths place. So what is 32 is what percent of 80? What's it going to be? 20%. Because I'm going to go 10, it's going to be 40%, right? 4/10, 40%, 40%. And actually I could reduce this down to 2/5, but I didn't want to because it's easier to go, either way. This can be 16 goes into here twice, 16 goes into there 5 times. And then I just think about fraction math. Don't always default to the decimal. So fractions are often easier. All of this computation can be done in your head, can it? Okay. Then the other thing we need to go through is many times. Let's go back to 96. 96 just happens to be what? 32 times 3, right? So when I do 32 over 96, it reduces to 1/3. Oh, what are you going to do about that? 1/3 is 0.333333333. So we're going to need to go directly to percent notation. So that means to add the percent, I am going to multiply back by 100, aren't I? So what happens here is I get 100 over 3, which is 33 1/3% exactly. If I do this through decimal math, number one, my division's a pain, right? I have to keep doing 3, 18, 28. Oh, and then I'm going to get 32 over and over again. So 33 1/3 is more accurate than 33.3. But when you're doing these problems, you will need to follow the directions. If the directions do not tell you to round, then you must go to the fraction. If the directions tell you to round to the nearest tenth of 1%, then you use the decimal form, whatever the directions tell you to do. So let's not ignore the fraction. Let's not always default to the decimal equivalent. Okay, so when we are going backwards, we do multiply back by 100. So to put our percent sign back on, we will multiply by 100, whether that's in fraction form or in decimal form. Multiply by 100 when it's in fraction form, do fraction math. Move your decimal 2 places to the right because we're multiplying by 10 squared. So, of course, decimal is easier. All you're doing is moving the decimal point, but the fraction is going to be necessary when you are working with numbers that repeat, or decimals that repeat, fractions that go on for more places, and so forth. Then, the last thing I want to go over before we start looking at specific examples is the idea of common fraction decimal equivalents. It's very, very handy to know these. So let's talk about our dollars and cents. Everybody knows that you can read 1/4. How? It's another way to read 1/4. A quarter. Okay, and we all know a quarter is 1/4 of a dollar, and we all know that a quarter is 25 cents. So that's 25 out of 100, or 25 hundredths, or 25%. It's no different than saying 25 cents is 25 cents, right? Two different ways to write 25 cents, correct? Two different ways, or three different ways to write 1/4. So when you're teaching 5th graders, introduce them to this group first. 1/4, they all know that a quarter is 1/4 of a dollar, is 25 cents, is written 0.25, and show them this little parallel. Especially the 5th graders. They already know money. Besides, in the United States, our dollars and cents is based also on what? Hundredth. It's exactly the same relationship. So just like if we're going to change the cent sign to the dollar sign, we have to convert it to hundredths, don't we? 2 places. So make that parallel. So your 5th graders who are going to have trouble understanding the idea of hundredths and out of 100, they can draw a parallel in their mind that they're already familiar with this. They're already familiar with the idea of hundredths because our dollar and cents is based on it. So what's the difference of doing this to this? Any difference? A penny is 100th of a dollar, right? A percent is 100th of a number. So we make parallels, and so this is a good place to start. And then you're going to bolster your students' confidence, and they're going to say, oh, this isn't so bad. This isn't as bad as my sister said it was. Just wait till you get to 6th grade math, or just wait till you get to 5th grade math, or wait till you get to 7th grade math. All right, so then what's a half dollar? It's 50 out of 100 cents, 50 out of a dollar. And actually this parallel is easier than that parallel, isn't it? So we already know that 50 cents is 50 cents. We also should already know that 0 holds the place, doesn't it? If 0 has to hold the place of the dollar, 0 has to hold the place of the ones place. All right, see the parallel there? It's really easy, easy, easy. Show it to the 5th graders. Then 75 out of 100, or 75 cents, or 75%, same relationship. All right, this we can show them the idea that what are we doing? We're just making equivalent fractions. There's all these things all dovetail together. That's an equivalent fraction. That's place value. It's just the next step, okay? So they should automatically know that 1/4 is 25%, half a dollar is 50 cents, so 1/2 is 50%. 3/4 add up to 75 cents, so 3/4 or 3/4 is 75%. So these should be automatic, easy gifts from the teacher, ones they don't have to divide out or ones they don't have to try to remember because they already have that. So we always want to, what did I just do? Yes, I tethered it. Okay, and do they know this? They start doing this in grade 2, plus they use it in their life. So you want to tether it, and that's going to be one of the main ways that you can reach their understanding, and the light bulbs can go on and they can see this isn't that bad. Oh, I see what's going on. They have to see what you're doing and understand what's going on. Otherwise, they're going to be just frantically writing down what to do and try to remember it, and then the decimal is going to end up just anywhere and everywhere. All right, so then the next place to progress are the fifths. As far as learning and understanding and even memorizing both. We're going to put it all together. We want to understand it, we want to see how it fits, and then we don't really have to memorize, but we can then transition away from our memory. And I'm not saying you don't use the flashcards and you don't use drill, but we want to reinforce the drill with understanding. And then when they're doing percents, they're not going to have to think about simple things like this. The first way that you can show this is equivalent fractions, which we've already shown with the quarters and halves. Let's make equivalent fractions. What's it going to be? 20 hundredths, 40 hundredths, 60 hundredths, 80 hundredths. And the next step is simply replacing the 100 with the percent sign. Oh, and look, I bypassed the decimal. Oops. Well, not oops. I don't need the decimal. Don't need it. Because this type of percent is always going to be easier to do fraction math on instead of decimal math. Decimal math, I just save decimal math for numbers that aren't nice fractions. I only do decimal math when I have to do decimal math. It shouldn't be the default. Hopefully you've already shown them. You've already shown them the idea. We can even go back to dollars and cents, but we don't have coins to go with it, so it's not going to be a good tether. But it might help them to realize that this is 20 out of 100, which is 20 cents, which is 20%, right? You should have already shown them this in the previous chapter on decimals. Right? 5/10, or 5 times 2 is 10, so 1/5 is 2/10 times 2. This is another equivalent fraction idea. Times 2, times 2, times 2, times 2. 8. 4/5 is 8/10. 3/5 is 6/10. 2/5 is 4/10. 2/10. 4/10. 6/10. 8/10, right? And so then this is just another extension of what I've already showed them in the decimals. Okay, so 1/5 is 2/10, or 2/10, 0.2, or 20 hundredths, or 0.20, or 20%. So it's going to be very handy to know these. And then you can even do this on flashcards and so forth. Then when they come across it, they're going to do much better, and the easy ones will truly be the easy ones. I showed you the other day about the repeaters. Let's review that. 1/6, 5/6, 1/3, 2/3. Okay? Well, the thirds is based on, some books call it the magic nines. I don't know if I want to call them the magic nines, but have you ever seen the fact that 9 ninths in particular always repeat through the numerator? Oh, 9 ninths. We won't do that one, because 9 ninths is 1. So, what is this? 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. What is this? 2, 2, 2, 2, 2, 2, 2. What is this? Oh, that's my buddy 1/3 in disguise, isn't it? This is going to be 4, 4, 4, 4, 4. You're going to keep dividing by 9. You're going to keep getting the numerator. 5, 5, 5, 5, 5. This guy. Also somebody I've kind of seen before. Repeat the 6. This guy will repeat the 7. And this repeats the 8. So, should we get into some math theory? 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. Does that equal 1? We won't do that. Okay, so we already know that when the denominator is a 9, it repeats. It also repeats when the denominator is an 11. But when we have repeating decimals, the percent either has to be expressed as a fraction remainder, or the percent has to be rounded. And typically textbooks will tell you to round to the nearest 1/10 of a percent, sometimes the nearest whole percent. So make sure you look out for that. If it doesn't tell you where to round, use the fraction. And the fraction is actually more accurate. So this is a repeating 3. So we don't really want that one. This is a repeating 6. Can't do a computation with a repeating unless we round somewhere, and then we lose accuracy. So if we're going to find one of these, let's say, to find this decimal equivalent, then we have to do fraction math, or percent equivalent. So we have to multiply by 100. And this is where you can get what you probably remember. 1/3 is 33 1/3 percent. Because 3 does not go into 100, does it? Not evenly. 99. All right, so then 2/3 is going to be 200 divided by 3 is where we get the 66, and we keep getting that 2, or we keep getting a 4, so it reduces to a 2/3 fraction, 66 2/3 percent. This, when you divide out 1/6, you probably remember, or if you don't, I'll tell you, it's 0.16 repeated, and this is 0.83 repeated. When we divide the 5, we will get first the 8, but then we're going to go to 20, which is going to give me the repeating 3. 6 is going to keep going into 20 3 times with 2 left over. So, same thing happens here. 6 will go into 10 one time, but then we're going to keep repeating with 40, 36, remainder 4. So this is going to keep repeating the 6. When we're dealing with this as a fraction, as a decimal, we would end up having to round this somewhere. Same with this, we'd end up having to round it somewhere. Usually the tenths, but it's much better to use this. This is a repeating 6, it's equal to 2/3. This is a repeating 3, it's equal to 1/3. Guess what students do? Is that true? Nope. Students will often do 83 5/6 because they're going on autopilot, aren't they? So we don't want them to use autopilot. We want them to understand this is a repeating 3, not a repeating 8/3 once we move the decimal. And this would be a repeating 6, which I rounded up to 7, so it's 2/3. And then we can reinforce this by memorizing the repeaters with the flashcards and by saying, nope, can't use 0.8333 in a computation, can you? And so when we come across the repeaters in the next section of the percent problems, we come across those repeaters, we have to use the fraction. So what if I have, what number is 66 2/3 percent of 39? We'll keep it easy with a multiple of 3. Normally, what do we do here? We're going to multiply because of tells me to multiply. What am I going to multiply by? 667? I don't want to multiply by 667. I want to multiply, I don't want to do this, 0.667 times 39. I want to do 2/3 times 39. That requires very little actual computation. So we want to do 2 things with our percent fraction equivalents. We want to teach our students that fractions are both easier and more accurate, especially if we have a repeating decimal. Okay? In this class, I won't accept the approximation. You see the answer here is 26. It is not 25 point whatever or 26 point whatever, is it? It's not. The answer is 26. So let's try to avoid defaulting to the decimal every time and looking to see if I have an easier fraction equivalent or I have easy fraction multiplication or easy fraction division. So it's very handy to know those fraction decimals equivalents, and actually it's not only handy, but it's necessary if it's a repeater for you to get the exact answer. We did this a little bit last semester, but we'll spend more time on it since it applies to intermediate. The last thing that I want to show you, these are very common in arithmetic and in intermediate math when we're introducing percents. We are going to keep the numbers simpler. So we're going to encounter the eighths. 8 does not go into 100 evenly. 8 doesn't go into 10 evenly either, so we can't do what we did with the fifths. We can't. So what we can do here is just go ahead and relate it to the decimal. If we divide this out, sorry, I forgot the one. If we divide this out, we're always going to get a 3-digit decimal. When we divide 8 into 1, we're going to get 0.125. When we divide 8 into 3, we're going to get 3, but then it switches to 7.5. Here the pattern is not very good. It is 3 digits always, and it alternates 2535 or 2575, 2575. 2535 was my phone number growing up, and so when I say 25, the 35 always comes out. 2575, 2575. Okay, so if we've learned this in our decimal section, then we can just kind of relate our fraction back to its decimal equivalent, and that gives us 87.5%. The half is always a preferred way, though there really isn't any difference between the two. However, in the textbook, on your assignment, you have to, if it says decimal, you use decimal. If it says write the remainder as a fraction, you have to use the fraction form. Follow the directions, even though these are equivalent, you have to follow what the directions tell you to do with remainders. So this is 62.5%. This is 37.5%. This is 12.5%. So this is worth showing them, and then actually you got to use a little more memory here because the pattern is not there's no pattern really. But they will encounter 12.5% frequently. They will encounter 1/8 frequently, so they need to recognize it, and it'll help them. So this is something you can memorize and help your students be quicker and more accurate, they can do problems more quickly and so forth. Okay, so let's take a look now at specific fraction to decimal to percent and backwards equivalents on section 5.1. Can you quickly and accurately, this is the first thing you have to do procedure-wise in percent math, is be able to manipulate the percent sign. Put it in, take it out, add it, and so forth. So the first section, objective A, is going from the percent backwards to its fraction or decimal. Dropping the percent sign, doing the division by 100. So if you look at page 205, you can see they're throwing a lot of the fraction equivalents at you. Numbers 1 through 16 are all pretty basic. So if you just look at any one of the odd problems, These are all just basic percent problems. They're going to throw a normal percent at you like 73. They're throwing an easy percent at you like 70. They're throwing a percent that can be reduced, 88%. And then number 9, and look there, they did it. They gave you a percent greater than 100, and they ask you for both. So this is practice saying 73% is the same as 73 over 100, or 73% is the same as what? 73 hundredths, not 0.73, okay? And then here they gave an easy one. That's really easy. That's going to be the same as 7 tenths. 70 and so forth. It's kind of funny that students tend to miss the easy ones. Because they have it in their mind that percent math is hard and it just can't be that easy. I have students that even miss this one. Like, okay, you guys are in Fairhaven Baptist Academy. I hope your parents have taught you how to tithe, right? And they even miss it when it's 100%. It's like, it can't be that. You know, 35 is what percent of 35? It's kind of funny, they just go through the procedure and they don't even look at it, I guess. I call those gifts because they're supposed to be easy and not requiring any computation. And many times students are confused by my gifts instead of helped. But anyways, so 70 is 7 tenths, which is 7 tenths. 70 hundredths actually, which is 7 tenths. 88 is the same as 88 hundredths, but it must be reduced. 4 goes into 88, 22 times 25. So you will have to make sure that you reduce, that goes without saying, or 88 hundredths. So 88% is 88 hundredths, is 88 hundredths, fraction form reduce. This one is greater than 100, so it's still hundredths. So it is an improper 5.1 and take the quiz.